Hello. Hello. Let's wait for some more people to join and then we can start. Good evening, everyone. Welcome to the second webinar of the conference webinar series, an initiative by Council of Architecture in collaboration with D.Y. Patil School of Architecture. I am Professor Mary Thomas from D.Y. Patil School of Architecture, Navi Mumbai. This webinar series is designed as a prologue to our upcoming conference under the overarching theme, Co-scripting Change with Disruptive Technologies in Architecture, Design, and Urbanism. This series has been thoughtfully curated to provide a deeper understanding of the conference themes and inspire active participation. Through sessions by experts, we invite you to engage deeply, share your perspectives, and expand your understanding of how these rapidly evolving technologies are defining and redefining our collective future. Today's webinar is on the impact of technology on design, collaboration, and sustainability by architect Krishnamurthy, which resonates well with theme 2 of the conference. Thank you all for joining us today. Let us dive into this transformative dialogue and explore the future we are collectively shaping. The session today will begin with the introductory address by the co-convener of the conference, Professor Aparna Surve, the Dean of D.Y. Patil School of Architecture, Navi Mumbai. Post the introductory session, we will begin with the session by our expert speaker, Architect Krishnamurthy. I welcome all the distinguished dignitaries, experts, and everyone to this session. Now I welcome Professor Aparna Surve, the Dean of D.Y. Patil School of Architecture, to give an introductory address. Over to you, ma'am.
Thank you, Mary, for very crisp and meticulous introduction. I extend my warm welcome to Architect Krishnamurthy for being part of this endeavor right from the inception and now and ahead. My deepest gratitude towards Council of Architecture for choosing us as the knowledge partner for co-scripting change in art and architecture through through technology. So this process started a few months ago when we wanted to launch a nationwide discourse through a conference in a format of a conference. That is where our esteemed Honorable President of Council of Architecture suggested that we host and curate this conference with the theme of disruptive technologies. As we were already planning to have a very contemporary dialogue, we thought this gives us a great opportunity to be a partner in this endeavor. While our team was working on this theme, we articulated 4 key themes. The first theme speaks about disruptive technologies in architecture and urbanism with perspective which runs across time. A kind of evolution is envisaged in this track. So evolution of disruptions and disruptive technologies as catalyst for change, and disruptions as societal transformations and build form impacts. The second theme is focusing on the established technologies, collaborations, and conflict. The track 1 of the second theme is about looking at contemporary disruptive technologies, collaborative processes, and development of these technologies in the context of architecture, design, and urbanism. Sustainable production of practices becomes a very important and inevitable track for this theme. The third theme looks ahead into future, which works with the emerging aspect or emerging disruptive technologies, symbiosis and sustenance. So the track 1 is designing for the future, vision, speculation, challenges and innovations as a response. And we do believe that the track 2, which speaks about multidisciplinarity, interdisciplinarity, and transdisciplinarity, is the only way in which we can even look at future through innovations and collaborative processes. So theme 3 is about that. Theme 4 is about looking at various examples and case studies. Because as we are having a discourse, the world is experimenting all over the countries and continents. The tracks would look at various projects, case studies, focusing on technology and focusing on sustainability. So we are looking at these 4 themes where researchers, scholars, academicians would deep dive into the chosen theme or the track and present research papers to the conference. The days of the do we have the slide for the days? Okay, the dates, sorry. So dates of the conference are 26th, 27th, and 28th of June. The calls for papers were already done. The submission of abstract, the deadline for submission is 3rd of February. So those who are present here, please do look at these themes and deep dive into your researches and do submit your abstracts on this. Beyond that, the regular deadlines are there. The detailed information will be circulated. I will request my colleague, Professor Mary, to share a link of the brochure by the end of the webinar. Can we go to the next slide? So this speaks about tentative outline of the 3-day schedules. The first day schedule will have eminent international and national keynote speakers. So we are hoping for BIG architects. We are hoping that Norman Foster Foundation would come here, and they have our brief and our themes have been greatly appreciated by those. We'll soon come up with the announcements of the keynote speakers. Following 2 days, we'll have online plenary speakers and offline plenary speakers who are experts in various themes. They have done work in either academics or in the profession. Along with that, we'll have research papers, presentations. So the 3 days is going to be an immersive experience in our journey in exploring what these technologies are going to, how it's going to shape our future. Yeah, and D.Y. Patil deemed to be University's Center of Excellence, which is again a building which is a platinum rated IGBC building designed by none other than Foster Plus Partners, a legendary international firm. So you're all welcome to visit the building, and we'll all be moving through various spaces, through auditorias, through meeting grounds and exhibition halls and so on and so forth. So this is something we are really looking forward to. And lastly, I wanted to also say that we have to kind of make this discussion and this discourse more meaningful and deep. We have organized 4 to 5 other supporting activities. One of the activities we already have conducted is the academic writing, advanced academic writing FDP, which was conducted by eminent scholars and experts, and many architecture and non-architecture faculty were trained under that. The next thing we are doing is we are hosting FDP, offline FDP, which is on-campus FDP, which is about various sub-themes and such as geographical information system, geographic GIS, robotics, artificial intelligence, and its impact on how architecture is going to be practiced, and augmented reality, virtual reality, and its foundational impact on architecture and the allied fields. And I'm very happy to say that this is going to be a multidisciplinary conference, because it is primarily hosted by our D.Y. Patil deemed to be university is Ramravadik University, which is one of the leading IT engineering institute, is actually taking a lead in this, and we are looking forward to present this offline FDP. So please, even this, if could be shared by the end of it, so participants could register. Architect Krishnamurthy is also going to be part of that. One more thing we are doing is an exhibition, because we think that such important, current, and dynamic topic will not be will not have a complete discussion without the industry participation. So we will be hosting exhibitions, and those exhibitions will be having presentations and demonstrations by industry partners, practices who are working with technologies, and even some student work which has worked with the this technology. So I think with this, I'm going to let Professor Mary introduce our esteemed speaker for today. This was the first webinar, launch webinar, where our COA president, Professor Jayashree ma'am and Dr. Sanjay Vidyarthi was the expert speaker, and I had the opportunity to speak about that. Mary, would you like to speak about the webinar before you start introducing?
Yes, ma'am. Yeah. So
Thank
thank you
you.
so much for your introduction about the conference and the pre-conference activities. So one of our important pre-conference activities, webinar series, and you're attending the webinar series, second part of the webinar series. So this is the calendar. So every fortnight we are having a webinar by eminent speakers.
Oh, and मतलब MA का course का it was one MA course was 120. फिर masters के लिए there is
Excuse me,
like
I request everyone to
कम होता है.
please
Ah,
keep muted.
masters of specialization would be come only, but 40 is also a good number.
I
वही
request
masters
everyone to
मतलब
keep
4 या 6 masters. And then there is ateliers.
uh,
So now ateliers are
so Myresh,
some things which are specialization in certain types of मतलब so you can opt for atelier. The studios are run across ateliers, or humanities or दूसरे courses are run as a year.
Who is speaking? Can you not stop this?
yeah.
Sorry.
Stop. Thank you.
Please go
Sorry
ahead.
for the inconvenience. As I said, every fortnight, every alternate Thursdays, we are having webinars by extreme eminent speakers. They talk about different themes and the tracks. So till June 5th, we have planned. So next webinar is conducted by Professor Aniruddha Paul. So he'll be talking about data analytics using AI. So you are all welcome. So at the end of this webinar, we will be showing the poster. So you can again log in and then register. So that is about the webinar series. So coming to our today's webinar. So today's webinar is on the impact of technology on design, collaboration, and sustainability by architect Krishnamurthy, which resonates with the theme 2 of the conference. Architect Krishnamurthy is a principal architect of Fold Design Studio. Fold Design Studio, initiated by architect Krishnamurthy himself, is an architectural design house committed to crafting a future where technology and design seamlessly intertwine. Together with architect Anishka Methi, the studio has redefined the discourse of contemporary architecture, pushing the boundaries of digital design and fabrication. From humble beginnings, the studio has grown exponentially, establishing itself as a powerhouse of design and fabrication, housing a team of architects, designers, and skilled artisans. Located in the vibrant city of Navi Mumbai with an in-house work lab powered by the latest advancement in digital technology, the studio is dedicated to building iconic designs that epitomize excellence, sustainability, and the perfect union of AI, 3D modeling, and the research. The studio's journey has been shaped by years of experience, research, and a profound commitment to bridging the gap between design technology and the built environment. Our mission, their mission is to inspire, create, and transform spaces through revolutionary architectural designs, furniture pieces, and artistic marvels. It's my privilege to warmly welcome Architect Krishnamurthy sir, our distinguished speaker today, to start this engaging webinar session. Over to you, sir.
Hi. Good evening, all. Thanks for that introduction. We'll quickly start with the presentation. Yeah, I hope the screen is visible.
Yes, sir, it is visible.
Good evening, everyone. So we're going to start with the lecture. So this is Krishnamurthy from Folds Design Studio. We are based at Navi Mumbai. We are going to discuss about the impact of technology today on how how the architectural practices are changing day by day nowadays in India as well as abroad. We are trying to adopt multiple details from the industry today and incorporate into the practice of architecture. So especially when we are working, when I'm saying technology, it doesn't mean only softwares, but we're also saying that how the machines are getting incorporated into the daily practice of an architect today, to whether it is an architectural project or whether it is an interior project or whether it is a practice where people are also trying to do some installations, doing some product designing, to various aspects in the practice of architecture, how technology is basically impacting. For us, being in the practice for almost past 25 to 30 years, but we have introduced technology past 17 years back and grown over a period of years to understand how this technology can change our perception in terms of changing the design language that we are trying to use today. So as the softwares have got incorporated into design, into our practice today, these machines are trying to help us out in a much better way, not only using softwares, but also using machines. We are ready to produce any design that is possible using softwares. Okay, quickly starting with the presentation. The kind of machines that we are looking at today is, I will generally try and tell you how these machines, what these machines are all about, and what are we trying to build with these machines. That is what we are actually trying to talk about. So this is a water jet machine. Probably we know what a water jet machine is, but what does it do? I mean, this water jet machine is basically there are two water jet machines that we have. These machines basically cut in a two-dimensional format. The basic process is using through water. The cutting happens through water along with a garnet, which is a 0.2 micron sand particles, which we procure from the market today. Using this thing, I mean the garnet and the water, with a pressure of 50 HP pump or a 30 HP pump, we try and send this pressure through a nozzle, which is here. You can see that. So with that, we can cut up to we can cut wood. Any material. Using this machine, you can cut them. Okay. So what are the outputs? So using this machine, what are the outputs that we have generated is we have tried to cut tiles, we have tried to cut marble and create these kind of patterns. So, this is a swimming pool that we had designed long back. So we have tried to use this as a machine and then generate this kind of a design. So it's a huge swimming pool that we had designed long back. This was done almost 15 years back now. And what else can you cut? I mean, we have cut ply, that's birch ply, and created that kind of a design pattern, a parametric design. We have cut metal and we have cut stone also and tried to clad onto a bench, sorry, a table that you're trying to see on the video on the right hand corner. So these are the things that you can do. What else is possible is what we are going to understand in the coming projects. So the other machine that we are looking at is a CNC machine. So what are CNC machines? So CNC machines are basically of 3, 4, 5 and 6 axis machines. So here what you're trying to see is this is a 4 axis machine which is actually trying to cut concrete. CNC machines basically deal with things like metal, wood, stone, solid surfaces, ply, concrete blocks, bricks, MDF and glass. So using CNC machines, we can cut all these kind of materials which are logically used today in the industrial practice that we're trying to do. So you can see the
Hello. Hello,
the same design.
Yeah. Your voice is breaking a little bit. I hope I'm back. Yeah, we are there. Yeah.
We can see you, but I think there was some small disturbance. I think now it has. Hello? Yeah.
Hello, sir.
Yeah.
We are back.
There's a disturbance.
There's a network issue. We are back.
Yeah, there's a network issue. Yes. Maybe you could speak without the camera on. Maybe that might help.
Is the audio on?
Yes, now audio is clear.
Okay,
And now we
okay,
can
fine.
see the
Done that.
projected.
You can see the screen, right?
Yes.
Yes, yes.
You can
Okay,
see
done.
your screen.
So this is a project that we have done for Bangalore Airport T2 terminal, where we have used, this is a 12 feet long bench where we have used three different plies, and we have nested the whole drawing onto these 3 different ply using a software. Then these were stacked one above the other. So these were stacked one above the other. You can see this kind of a pattern which was got created. They were stacked one above the other, and then we have grinded them out. We could have used a CNC machine also to get this project done. But since we were busy doing other projects as well, we thought, we'll use a manual labor and then get the job done. So here, what we have done is we have stacked these ply that was cut into numerous pieces. They were stacked one above the other. And then the grinding was done to achieve the actual form. Over and above, what we have done is nowadays what we are trying to use is we have done a lot of research on spraying this composite marble. So we have used composite marble as the base material and the outer surface as well, so that we can protect the ply. So that was the basic intent, and then create this whole like ourselves. So
Sorry, sir, your voice is
basically,
breaking again.
you can hear.
Yeah, we can hear, but your voice is breaking a little bit. The screen is visible.
Is it okay now?
Yeah, we can hear you now.
Yeah.
Yes.
Okay. Okay. You can hear me.
Yes, sir.
Yes, yes, yes.
Yeah. So we go. I love. CNC was have to created which Kadapa local stone, which is just a 30 rupees a square feet stone, and these kind of beautiful designs or details. These are typically Indian details that we wanted to produce for one of the spa that we are doing. On the right, what you're seeing is a living room detail where we have engraved with the stone using again CNC machine on a petal format and inserted brass into it. Okay, so these are different kind of designs that you can produce. What you're trying to see here is, this is a staircase that we are actually trying to make. We have cut, to reduce the quantity of wood, we have cut wood into small pieces, then stacked one above the other. And then we have engraved it using CNC machines. Inside, we have a metal bracket, which was cut with laser machine. And then we have tried to create this kind of a staircase at the end of the day. Okay, so these are the design details that you can produce. You can cut, we have engraved a wall which is like this. You can cut wooden blocks again, stack them and create benches. So these are multiple, you have stacked wood again here, and we have engraved which could look like a curtain. So multiple things can be done using CNC machines. So it all depends upon how you're going to use the machine. So next is a metal laser machine. This is a metal laser thing. So with this, what we can do is something which I'll tell you. Here in this case, we are trying to cut metal where we can cut up to 12 mm. So that is 1 to 12 mm is what we can cut MS. If you're cutting brass, stainless steel, copper or aluminum, you can just cut up to 3 to 4 mm. Only because it's a shiny material. Okay. So that's the reason why you can't cut more than 3 to 4 mm if you're using brass, steel, copper or aluminum. But MS you can cut up to 1. This is that you can cut it with air is basically you can reduce your cost. The whole idea is to reduce the cost of the project. When in architecture especially, we don't cut more than 6 mm. 12 mm is all industrial purpose. In architecture, I think 1 to 5 mm or maximum is 6 mm. Even if you're designing a staircase, it's maximum 6 mm that we are basically using. So what have we done with using this machine? We have cut, we are doing a building here. This is a parking building. We are doing it in Alibag, which is like this. This is a bungalow roof that we have made using laser machines. So this is an interior space that we have done. So here, this is a public art which we have made here. And then this is an installation for Aztec that we have done. So using metal, what all can you do? Using a metal laser machine, what all you can do? So these are things which are possible to think, to design, to understand the software, understand the G code processes, and then understand the machines and then build them. So multiple processes do happen using these machines. So that's how things can be done. Then using a non-metal laser machine. So we have a non-metal laser machine as well. These are machines which people, the colleges are using extensively today. Every college has got a non-metal laser machine today. But using a non-metal laser machine, what all can you do? So we usually do, I mean, we make models. That's what we tend to see. But in this case, what have we done? We have done panels like this. We are doing a table base, a dining table base, which is coming up like this. We have done a lobby where, we have cut MDF and pasted onto it like this. Then we have done a long model, a huge model in one of the walls as an installation in one of the projects. We're using a non-metal laser machine. This is something which you can also do. But not only that, on the right, what you're also trying to see is a glass. So we have done a glass installation where we have engraved glass using this non-metal laser machine. So this is something which people don't know, that using a non-metal laser machine, you can also engrave tile, you can engrave glass and create installations or create different kind of design details. That's also possible. So this can only happen provided you are trying to work with machines in a bigger way. In our case, in the lab, what we try and do is we completely work with machines all the time, understand what these machines can give us today, the materials that we are trying to use, how we can use different machines and create our own designs. So the whole idea is that. Next is 3D printing tools. We all know what 3D printers are today. I don't think this is something new for anyone, but using 3D printers, what are the kind of designs that you can build? Because many a times people are using 3D printers only for making small models. But 3D printers, we are using 3D printers in an extensive way and creating much bigger designs. So this is a dining table base that we have created. So the whole 3D model was first done on a software. It was divided into multiple parts. And then it was 3D printed using 3D printers. The multiple pieces were printed. They were joined together. Now, when it is a dining table that I'm trying to say, it also is going to take a load. So what we have done is we have inserted steel cables inside this, steel rods inside it, so that we can maintain the strength of the table, because we're going to put glass on top of it. So that's how the table was created. Other than table, what else can we do using 3D printers? So this is a sofa that we have done. This is the back of the sofa, which was 3D printed, and then casting was done to add in this kind of a design detail. This is the other sofa that you're trying to see, again using 3D printing methods. That's a chandelier that we have done using 3D printing again. This is a bench, that's a chair, that's a wash basin. So there are multiple details that you can produce using 3D printing technology. So 3D printing doesn't mean that, to a certain extent, 3D printed outcomes are only used basically for small, design solutions. But in this case, you can change the idea of using 3D printing, the end product of the 3D printing, by converting them into molds, then using different technologies, especially like, resin and marble powder, combining them and create the different kind of designs like this and produce them. So these are functional pieces now. These are all functional art that we are looking at. Rather than just an art piece, we are trying to make functional designs. So chair, ergonomics necessary, creating that kind of a chair and producing it, at multiple pieces, making a mold out of it and making multiple pieces so that the cost reduces. So now what has happened is, by using 3D print technology, we are trying to reduce the cost and get the end output. These are multiple things that you can do. Using concrete 3D printing, of course, this is not my lab, but we have collaborated with one of the labs at Pune. Doing a little research, concrete is still at a premature stage. Yes, people are trying to build, 3D printed homes or 3D printed buildings on a much smaller scale. What I think about 3D printing in concrete is about doing all this organic forms, or, those complicated designs that probably a human can't build. So 3D printing should be used at that area where, we can 3D printing of concrete, especially we should use 3D printing concrete at areas where human can't do it, especially making the staging process, the lower formas and all, where you can obsolete all that and use 3D printing as a methodology and create those buildings. So this is at a premature stage. We're just doing R&D. So they've already done, they're doing for JSW, they're already built detail Still, problem is to then it becomes too expensive and you will not survive just doing research. So end product has to be there. When we are working with smaller products like, PLA, PETG, ABS on the smaller 3D print machines, it is still sustainable, it is still achievable, and you can still survive. But using concrete 3D printing, it's a little difficult process. Then something called thermoforming is something which we are also trying to use. This thermoforming is again, we have a large machine. On the left side, it is a heater. On the right side, it is a compressor. So by using thermoforming machines, what you can actually do is make a small mold. Same design detail can be multiplied. If you want 1,000 pieces, you can achieve within a period of a week's time. So multiplying a same product is something which you can actually look into. So we have made a small mold here. So that's the mold that you're trying to see. Then the mold was put into the compressor. Then materials like your acrylic materials, like your solid surfaces, materials like composite wooden slabs that come nowadays. This is a rel ply. So this is a composite slab that we are looking at. It has got a wooden aggregate. I mean, it has got raw wood, and you have resins with hardness mixed. They make these slabs. So where we put these slabs into your heater, change the temperature of the product, change the density of the product, and then put that onto the mold. Through the suction of air, you try and create this kind of design details. So we were doing a ceiling at one of the projects in Mumbai. This is the ceiling that we have achieved, by using thermoforming design process. This machine. You can also create these kind of lampshades by using acrylic and the molds. So multiple pieces can be derived in a very short period of time. So same design, if you want to multiply, you can use only thermoforming can be done using only 3 or 4 different materials that you need to understand. So today, logically speaking, we have got only materials such as composite materials, that is rel ply. The other thing is Korean, that is solid surfaces that we are looking at. Then you have acrylics and polycarbonate sheets. These are the only sheets that you can work with in the field of architecture by using thermoforming machines. Then comes robotics. Yes, robotics is again a major thing that we are trying to use. In our factory, we have got 4 robots, but we are still trying to find out ways where we can achieve certain kind of designs. By using robotic arm, what are the things that you can do? You can do sculpting, you can do engravings, you can do 3D printing as well. Materials are what? Materials like stone, concrete, styrofoam, wood, plastics, etc. can be used, and you can achieve an end product. What we have done is recently we have 3D printed a column which is of 2 meters height. So using the process of pellets. So this is the cheapest way now where you can use pellets, pellet extruder, and create or 3D print up to 12 mm thick. That's the whole process that we have reached today. You can just print up to 12 mm thick using pellet extruder. You can build columns, multiple pieces joined together and get the end output. So that's the basic idea. If you're using pellet extruder and putting it onto a 3-axis machine, the robotic machine has got its own limitations. But if you're putting it into putting the pellet extruder onto a 3-axis machine XYZ, where the CNC machine, the XYZ machine is almost 20 feet height with 20 feet by 20 feet, then you can actually print using pellet extruder, you can print a home. So that also you can do a lightweight printable homes, which can also be transferred from one place to the other. So these are the new things that you can achieve. So I mean, these are things that you can process tomorrow. So that's the future of architecture. So at Folds, what are the softwares that we are trying to work with is on the left side, we have shown you Rhino, Grasshopper, Blender, 3D Max, NestFab, Cura, Desproto, ArtCam, Mastercam, and RoboCam. These are different kind of softwares that help us out in terms of designing our models, computing them, and then also trying to create G codes, and then so that we can pass it on to our machines and extrude our designs. So on the right, what you're trying to see is the machines that we have today. So these are the different kind of tools that today every architect should understand, because these tools are generally used in the automobile industry or the aeronautic industry, but these tools are not actually available to the architects today. But we have our own factory setup where we try to get all these tools into our lab, and we are trying to work with them in a much bigger way. So what are these tools? These are power tools. Then power tools are something which every carpenter uses. But other than that, you have CNC, that's 3 axis, 4 axis, and a rotary. You have water jet machines, you have metal laser machines, you have non-metal laser machines, you've got thermoforming machines, 3D printing methodologies, robotics. So these are the tools. Other than this, the manual process is necessary today. We have not completely gone onto the machining process where, the machine is giving us the end product. We as manual process, which is necessary today. So still we are trying to work with things where, the technology has not gone that high in India today. We are all trying to still understand technology in a much bigger way, because there are multiple failures that do happen, but also trying to practice, deliver projects, create projects, deliver projects, and also understand this technology and then practice. It's not an easy thing, but still we are trying to drive the show in a much better way today. So to understand and get these new things into our lab and then obsolete the manual process, maybe it will need another 3 to 4 years or 5 years down the line, so that we completely work with machines and get our end process. So what we call our designs as today, we call them as functional art. So combining architecture, interiors using softwares and computational methods, the AI technology which has recently come into our this, the human intelligence that we talk as HI, the machines and the fabrications, compiling all this, we call our designs as functional art. So whatever we are trying to produce is all functional designs. So as an architect, I just can't design art, but I also need to design something which is basically would be used by the user I'm designing for. Okay, so we call it as functional art. So coming to the projects that we are trying to do, this is one of the installations that we did for T3 Delhi International Airport. This was one of the projects that we did long back. This was done in 2017. So this is an installation which had come to us where we were supposed to build only gears. We took up as a challenge, and we thought, rather than just building gears, which are just moving, in a format, why not we add a little more depth into it? So we thought we will convert this gears into a clock, which actually shows time. And on the right, the head, which basically is thinking throughout the day. And all the things that it is thinking is basically with respect to the time. The whole concept was that. Initially, when it came to us, we thought it is just a flat surface, but it became complicated. You can see those 3 lines. That's where the angle changes. The whole clock, the whole installation changes at an angle of 45 degrees and then again goes back to the normal plane. So that's the installation that we did. This is the fabrication process that I'm trying to show you. So it's in metal at the initial stage. The back is in metal with these pipes behind, where we have bolted this whole metal installation on top of that. And then the gears were cut using CNC machines. The whole process went through certain kind of calculations that we had to use. We had to use a software where the gear calculations were done and then, the interlocking details were done. So we had to use gears, and then some bearings were used. The lock bearings were used so that we can attain the stability of the structure in a proper way, because these gears are continuously moving. So that was the process. This is again at the initial stage where we were trying to understand how these gears are going to move. We have got some rectangular gears, some hexagonal gears. All these were compiled together to form this kind of a detail. On the right, this whole thing is working with machines. We are just trying discipline. Okay. Minute.
Sorry, sir, your voice is again breaking.
You can hear me now?
Yes, now
Yeah.
we can.
Okay. So that's the recent video. The clock is still ticking. It is still showing time. We are so happy that as architects, we have changed the thought process of entering into a new dimension. We're also trying to calculate to a precision where a clock can show time. You know, creating a clock is not an easy thing because it's the most difficult thing in the world. So we have tried to surpass that. So we try to understand that, you know, as an architect, when we're trying to practice the architectural design language, at times half an inch, 1 inch, at times even, you know, 2 inches or 3 inches or 100 mm is also neglected. But here a precision is necessary, and we try to attain to you know, the precise detail and try to create this kind of a design. Then this is a table that I'm trying to show you. It's a small installation. It's a dining table for a marble company that we had designed. Initially, when it came to us, we were also working with 3D printing technology, but we miserably failed while using 3D print technology because it was a very early stage. We actually did not understand how to use 3D print methods to execute this project. But over a period of time, yes, now we have become masters in it, and we use 3D printing in a much bigger way. Every project we do 3D printing. So this is a table which had come to us where we were supposed to use marble as the main material. It was more like an installation. So we thought we will use the same marble which we used on the floor as well, so that we feel that as if the whole table is actually emerging from the floor. So the basic concept was that we could have used solid stones also, the solid block stone, but carving it out and getting the end product would have been very difficult because stone is not very easy to handle. And once it is done, you are also supposed to transport it. Shipping may also cause breakages. So hence we thought, you know, we'll not use stone as a complete stone, solid marble, but we will use stone in multiple pieces. So we went back. The whole process was done using the software technology, and we tried to cut that into multiple pieces using just 4 stone slabs. You can see the nesting unrolling process. Internally, what we thought is we will have this metal structure, which we tried to cut using tessellations and cut using laser machines. Then we joined them to create this kind of a structural, you know, stable structure inside, over which we, you know, pasted the marble, so that the whole marble was pasted one above the other, so that we can achieve or attain this kind of a design detail. So that's how the whole process went on. And then when we pasted onto the stone slab, we have achieved this kind of a design process. So you can see that each and every stone piece is a grain. As from idea, and the next which 5 floors. The building is a 32 stories. A first structure, 32 stories steel. Opportunity. IT and IT. Bureau. The
Sir, your voice is breaking.
Am I back?
Yes, we can hear you now.
Yeah. I'm back, right?
Yes, screen is visible.
I think there's some. No worries. Okay. So we thought, you know, we will change the basic style of working on the facade. We thought using a Uh, I think there is a bad network here. Yeah.
It went on quite nice for some time again.
Yeah, 1 minute, 1 minute. I'll change the network 1 minute.
Okay.
Yeah, just a minute, give me. किसका Yeah. ये बंद है क्या कनेक्टेड है ना लैपटॉप से क्यों उसको कनेक्ट किया है
Sir, your mic is not muted. ना-
Uh, Voice is not clear. Some network issue.
Yeah. Are we there now?
Yes, yes, we can hear you.
Okay, done. Okay. So, while we can go ahead, right?
Yes, sir. Your screen is visible now.
Done. Yeah. So, this is the project that we were talking about. So here we have used high density bricks. So these bricks were cut into multiple pieces. It was a 1 lakh square feet of a surface where we were trying to work out with. So we have used high density bricks. We have got it from Mysore. We have cut them into 6. Each brick was cut into 6 slices. To cut this also, we have built up machines. You don't have this brick cutting machines at all here. So we had to build a machine where we could cut almost 20 bricks in one go. So this was a huge machine that we have built and stacked brick one above the other, next one next to each other. And then we have cut multiple pieces at one stretch. so that we can achieve these bricks to be cut within a time span, because 5 lakh pieces, 5 to almost 6 lakh pieces, it was not an easy task. So at a time span, we were supposed to cut those pieces and give it to our laborers so that they can start fixing it. So we try to create this kind of a design pattern. This was not done through using computational process at all. Just by using different kind of a patterns, using the materials, we have tried to create patterns, and then we thought this would be the main detail of the facade of the building. And at certain areas where we are having windows, we'll have a jali. So the whole idea was that. So we have used multiple thought process to get the brick fixed onto the wall. So these were the patterns. In this case, what you're also trying to see is there are some bricks which are cladded vertically. So in that case, the surface of the brick is just 12 mm. So using the right adhesive is again necessary. That's very important. The other biggest part is using products like this, materials like brick. The biggest challenge is the weather. During monsoon, the brick may catch algae. That is something which we all know. But in this case, what we have done is we have used, we have tried to protect the brick in such a way that we have dipped each and every brick piece into a nano coating chemical, sealed it from all the 6 sides, and then we have pasted it so that this brick doesn't catch algae. So that was the major part here. So now it's almost 4.5 to 5 years now the brick facade is done. We don't have algae getting generated or getting created or on the surface. Still the brick is clear. What we have understood is the nano coating materials. By using these materials, you can protect your brick up to 5 to 7 or maximum 8 years. So that's something that we have tried to understand. Once it is done, I mean, once you cross 6 or 7 years or 8 years, you can coat it with the nano coating by just spraying above the surface and then attain the material's quality so that the algae doesn't grow and the facade looks the same. So that's what we have tried to work out. So this was the facade. Brick, being a small material, it was very easy to clad. It was very easy to clad by just doing the staging on top. But the most difficult part is achieving them fixing the brick in a straight line. That was a major challenge here because the facade was almost 120 to 130 meters long. It was not an easy process at all. Achieving that was the major, hitch, the glitch here. We have tried to make sure that the flaws that you're trying to see. So that's the jali you're trying to see. What you're seeing it from the inside of the parking bay. So here we have cut brick blocks into half slices and then stacked them one above the other. The horizontal pieces where you're trying to see the stacks is just 12 mm again. So we have tried to bond this with that 6 mm bonding agent. That's the most difficult part. The other difficult part, what I was trying to say at the initial stages, this is a steel building. So steel building has got a lot of vibrations. That is very important. Again, we need to understand. So it has got a lot of vibrations, that part one. Part two, it is a parking bay. So every time there is a movement of a vehicle inside. So whenever there is a movement of a vehicle inside, there are certain kind of vibrations that get transferred onto the surfaces. So, we need to understand what kind of adhesives or the protective bonding agents that we are trying to, use here. So there are a lot of calculations that went through. End of the day, we could procure these materials where these adhesives that I'm talking about, where they gave us years. One minute. I think there is some network problem here. Are we back again? Good to go?
Yes, sir.
Yeah. So we were also doing the interior spaces. We are just trying to understand how technology is trying to help us out in terms of, help us out in terms of designing these kind of complicated details, uh, get inspiration from these details and try to produce them from a sketch to a computational design program, and then convert them into G codes and cut them through machines and then execute them. So this is a multiple process. So here we tried to mimic the tree as a sculpture. This was a large interior space that we were doing, a 20,000 square feet of a space, almost 120-meter long structure that we were trying to do. So this was spread across 16 meters by 120 meters. We didn't want anything on the ceiling other than the sculpture. We wanted a sculpture which is supposed to be an interactive sculpture. So we wanted people to understand that these spaces that they are trying to enter in don't look similar or to see.
We've lost the screen again.
Major
Something is.
problem with the network. Can you give me 1 minute? Can you just give me 2 minutes? I'll change the network.
Yes,
give me 2
yes,
minutes.
please. Yes, please. Please.
No worry.
Yeah, are we there?
Yes.
Okay. Can we go ahead?
Yes, sir.
Sorry. I don't know what happened. Usually this doesn't happen. Extremely sorry. So, just get me some water. So, this was the installation that we were talking about. So just making a 3D design or a 3D model was not, explain to the class. And model will space. It in
Sir, again, I think there is a network problem. The voice is breaking.
I don't know what's happening today. Usually this doesn't happen. इसको लेके चलो। Are we okay with it?
Yes, sir.
I'm extremely sorry. I mean, this never happened. क्या हुआ है?
That is okay, sir. We are eagerly waiting for your presentation.
This usually doesn't happen, but just wait for some more time. I'm just trying to.
It's looking wonderful. So you don't want to miss it. So these models, the scale models are done in what? They are 3D printed.
These are 3D printed.
They're 3D printed.
Yeah.
Okay. Very nice. In fact, do you want to take any question and answer in between or something? Or we should wait? I think we should finish, no? Full thing, that's better.
Just wait.
Yeah, yeah.
But we are on, right? You can hear me.
Yes, now we can.
Yeah, yeah, fine. Okay. So let's go ahead. Let's see if it.
We can't now. Your voice is not there now.
It's not there.
Okay. Maybe you are not
It's
speaking.
not there.
Now it's coming.
Is it there now?
Yes.
It's coming. Yeah. Okay.
Yes.
Okay. Fine. So we had to 3D print these models and understand how they're going to actually behave inside the space, even with the human figures inside, because the space, the height of the slab was 9 meters. That's what the height that we got. And putting this huge sculpture inside was the most difficult thing. So 80 tons of load was supposed to be taken care of. And the biggest part is having this 80 tons suspended from the ceiling. That was the major part. You know, it's not just having a sculpture which is actually suspended from the wall. I mean, it's the loads are transferred onto the walls, or it is actually from the floor. This whole sculpture was actually suspended from the ceiling. So the basic, the most important thing was to understand how this will get suspended. So hence, we had to prepare this model and understand whether it is feasible or not. So we made this model. We went to the structural engineer, tried to understand that, you know, how this can be placed inside the sculpture and which are the number of points where we can suspend this from. So finally, you know, we can't have huge cables through which we can suspend this. But we got one of the companies which is called Hilti. They have a cable where each cable can take a load of almost 300 to 600 kgs. So, you know, getting this cable in place was like a blessing to us, because we didn't want this sculpture to be seen as if it has been hung from the top. We wanted this whole ceiling to be like floating in air. So the whole concept was that. So with having the 6 mm thin cables, just 200 cables is what we used to suspend the whole ceiling from the top. On the left, what you're trying to see is, you know, we have unrolled the metal metal sheet that we have tried to cut. We unrolled the whole surface, and so that we can create this kind of a design. Structurally, it was feasible. Then we took the whole thing onto the site where this whole thing was done in metal. On top, we have encased with MDF so that we can get a proper finish. So that's how the whole sculpture looks end of the day. You can see those cables, thin cables. These are very thin. Yes, of course, the photograph could capture it, but when you're inside the space, you actually don't see these cables. Because of the light and everything, you don't actually see those cables. They are so thin. So each cable was placed in such a way at certain points where it can literally transfer the whole load to different areas, and it can be suspended from the ceiling. So this was the sculpture. Then there was a reception table, the information desk that we designed inside this space using computational tools again. The table is looking as if it is a tessellated form, but don't think that just having a tessellated form is very easy to achieve. Yes, tessellations are easy to achieve, but the most important thing and the most complicated detail was the lines. The T-code lines that you can see, these number of lines from one edge to the other edge when they were transferred, these lines actually change the surface and change the size. Every time the line of the triangle changes, the size of the wood also changes. So the most important thing is transferring these lines from one end to the other, taking it to the whole surface of the object was the most complicated thing. So this was a 25 feet long table, not an easy table to achieve. But the most complicated thing is those lines which you try to see. So using computational tools, this becomes much easier for you to understand and make sure that your carpenter, your artisan who's working on the table also understands this language. So we could achieve this design. Then the other benches that we tried to make inside this project were all sculptural. The whole space to sculptural and an interactive space rather than just having a typical sofas or typical benches, or use marble cladding, use Italian marble and create the space. On the floor also, what you're trying to see is quota. We have used basic quota here. Rather than increasing the cost, we thought we'll reduce the cost, use Indian marble, which is a quota, which is slate. We tried to get a grade in quota also. We get different grades. There is the A grade, B grade and a C grade. So A is the worst grade, basically in the language of quota. B is the next worst. C is the best. Okay. So C is something where, you have to go up to a depth, when you're cutting quota, you have to go up to a depth of almost 100 meters below the ground where you get the best quota available. So this is again a research. So it's not easy, just buying quota from the vendor is very easy. But understanding what kind of a quota you want so that, we have very less variations in quota. So that's the reason why I'm saying that, when we used quota, it was a big challenge for us. We thought we'll have less variation in the whole space, 20,000 square feet, one lot we had to get from below 100 meters of the ground level. We tried to get this quota and achieve so that, 98% of the quota was matching, only 2 to 3% variation was there at the end of the day. So again, these benches were made, which were again all sculptural. They were not just benches, but they were all sculptural. When people come and visit this space, they feel as if, they're trying to see different kind of furniture in the space. They sit here, they understand that, the spaces are completely different. Then the lift information bots, in the same space, we also designed lift information bots because it's a commercial building. It's an IT park building. People are trying to move in and out. We didn't want a typical kind of a panel that we usually tend to see in the lift lobbies. We thought we will design a bot, which I mimicked it from, I tried to get inspired from this movie called Big Hero 6, the microbots. People might have seen these movies. So, I tried to get inspiration from this movie, which is a microbot. I tried to convert that into a lift information bot where this kind of a design was detailed out. So using CNC machines, using birch ply, we have cut them into multiple layers, stacked them out, tried to understand how my pipes are actually going to go. Those pipes, those cables that you're trying to see, they are supposed to take my information. I mean, especially the cables, electrical cables and the Cat6 cables. So this was designed like this so that we could achieve this kind of a design detail end of the day. These pipes that you're trying to see, these bots are actually floating in air. These pipes actually carry those cables, the Cat6 cable and the power cables, so that, when a person comes here, he uses these pads as to send the information to the lifts, and then he understands which lift is he going to take, and then he goes to that lobby. And the whole idea is when you're coming into this kind of a space, you're trying to use these kind of interior products. The user, end of the day, the user actually feels very happy that, he's come into a completely different space, a sci-fi space that he's actually living in. So the whole ambience, we thought we'll create that kind of a design so that it becomes a completely interactive space end of the day. Then coming to a different project. So, that was the interior space that we designed. This is a different project. This is a bungalow project that we were doing at Bangalore. So these are huge columns that we have designed. So this is almost a 1 lakh square feet of a bungalow we were designing at Bangalore for a client. The client had an appreciation to the White House project. So he also wanted to have the same kind of a building, same kind of a design detail. But since we are completely into computational programming, completely into a parametric design world, we thought, why not change the style of columns that generally people tend to use, rather than having the same Corinthic or the Doric order columns. We will try and change the style of the columns. So in this case, we thought we will go for some organic shape, a fluid design kind of a detail on the columns, which are mimicked from nature. So we thought we'll use that kind of a design process. It was not easy for me to convince the client this kind of a design detail, because he didn't know the outcome. Once the columns were designed, what will be the outcome, because he has never seen these kind of columns. So client was adamant that he wanted the same kind of columns that the White House had, or what we try and see all over Europe. But it took a lot of time. We had to tell the client that the columns can be of these different kind of design philosophy. Still, after even showing him all these kind of design methods, we could not convince him. So we had to present them by projecting a stone map onto the column, so that he understands it in a much better way how these columns would look like. But still, we could not help him out in such a way that what we wanted, we could convince the client what we wanted. But end of the day, we had to make sure that we print a complete 36 to 40 feet height column to convince the client and tell him that this is how your column is going to look like. So we 3D printed the complete column so that the client understands how this 30-40 feet column is actually going to look like in front of his building. So we were actually doing almost 40 columns, 22 columns were outside, 8 columns were inside. So there were almost 30 columns. So it was not an easy task for us to make sure that client understands what we wanted to give it to him. So after printing this 32 to 40 feet height column, he was very happy that his column is actually going to look like this. So then once the finalization was done, we went to the final process. So executing this column was not easy. We could have also made a mold, because all the columns were similar. We could have also made a mold to achieve this, but using a mold was not the right choice, because details were not only on the surface, they were also internally, the details were going in, as you can see in the column. So we thought we will use CNC machines and use lightweight concrete blocks, so that the cost also reduces. So internally, the column had this structural column over which we cladded this whole horizontal pieces. This number of pieces, 2-inch thick blocks, which were cut into multiple pieces. They were stacked one above the other. On the center, what you're trying to see is the 3D printed column. These are the design details which we wanted to achieve. We could not have achieved by using a mold. So we had to stack them one above the other, create this kind of the design process on multiple columns all around the building. End of the day, create that kind of a design detail from your 3D model that we showed him end of the day, so that we can achieve this kind of a design detail and make sure that these columns create that kind of an aura, design language, which is very important today. So all this is possible using tools. Without tools, it is impossible. So if you understand how these tools can produce things for you, it is much easy. So end of the day, we could achieve that. The project is still going on. We are at 60% completion. So, the columns are there. You can see from the design language that the initial presentation that we did, the things that we tried to convince to the client by 3D printing the whole column. End of the day, we could present it to him in this way, and the columns are ready. So the best thing is when you're using digital technology and using machines, what you need to understand is, from the first cut of a design to the end process, there is no loss of information. So your designs from the start to the end, you will have the same detailing. So many a times what happens is designing becomes easy, but execution becomes hard and tough. But having said, if you are having machines and you understand the language of machines, then you can produce your end product as you show at the early stage. So there's another project that we did, we are doing, this is also in Bangalore. This is a bungalow that we are doing, a 9,000 square feet bungalow, which we call it as a brick house. So it's completely a load, it's not a load bearing structure. It has got columns inside, but it's completely designed in a parabolic format. The whole roof is completely in a parabolic format. But the best thing is here, the whole roof is just 20 mm thick. We wanted the whole roof to be as thin as possible and still take the load. The very important thing is people can literally move on top of this, even though it is just 20 mm thin slab. So the whole structure was designed having courtyards inside, like a courtyard planning was designed. It's a 5-bedroom all kitchen bungalow, a 9,000 square feet of a construction area on a 20,000 square feet of a plot area, which was parallel to a highway. This was at Kolar, 70 kilometers away from Bangalore. We wanted the landscape to move in and out. So initially the design was presented in this way. The facade was supposed to be designed with brick. So everything, the brick inside is brick outside. So the positive is outside, the negative is inside. We didn't want to do plaster on the building at all. So we wanted to use the clay bricks as it is. So, and then have wooden cladding on top at the bottom and then the roof on top. So we designed this by first thought, we'll make a model first. That's what we generally do. We make models for every project that we do. We understand the technology first. In this case, we were the structural engineers, because structural engineers lifted their hands up saying that, this is not possible for us to design and build it. So we had to take up a challenge. We had to become structural engineers by ourselves, create this kind of a design, make sure that this is possible. We made a waffle structure at the initial stage. Then to make the structure, the facade done, we had to create this kind of analog for our carpenters, our kadiyas on site. We literally try to number each and every brick where that brick is supposed to be placed. If number 4 is there, the number 4 has to be placed a half inch away from the initial plane. If 3 is, then it has to be placed 1.5 inch away from the initial plane. 2 similarly, 1 similarly. So that's how we had to convey our information to our laborers so that they can achieve this kind of a design detail end of the day. So this was the design process that happened so that we can tell them how to place the brick, where to place the brick, and end of the day achieve the design. So this was happening all at Kolar, 70 kilometers away from Bangalore, out away from the city. We are sitting in Mumbai. Sending the information from us to our laborers was not an easy task at all. So that's the design detail that we could achieve. So that's the process. Everything is brick. We didn't want any plaster on our surfaces. So that's what we could achieve end of the day. Internally, it was cladded with wood. We changed the design. Rather than having perforations, we thought we'll have simple wood going all around the space. The wood was also acting as a barrier where it was reducing the heat from the top. That's the basic purpose. The other thing is the whole waffle structure was done. You can see the waffle structure. Then above which we designed this whole slab in a 6 mm thin metal sheet. We cut that into multiple pieces, triangulated surfaces, took that onto the side and then welded it into multiple areas and got this kind of a roof done. So you can see it's just a 6 mm thin roof. The whole design was changed at the end of the day so that, the parabolic curves can come from bottom. I mean, they can go from bottom to the top clad and then again come down. On top of this, once the whole roof was done, on top of this, we used 12 mm thin slices of lightweight concrete blocks. They were pasted on the metal so that they act as a barrier so that they can become a waterproof structure end of the day and also reduce the heat internally. So the wooden thing inside and the top concrete on top, it completely reduces the heat inside. So that was a basic factor. So at end of the day, we could achieve a 20 mm thin slab. After completing the project, we took the design to the structural engineer so that he can help us out in terms of saying that, the structure is stable now. So finally, the structural engineer has to say that the structure is stable. The calculations are perfect. Today, he is in a position to help us out to do these kind of designs on multiple projects. So it has become easy for us today. So that's how it looks like. On the left, you can see people are working on top of it. On the right, the project is still going on. The interiors are happening now. So the slab is done. The roofing is done. The waterproofing is also done now. Then from the buildings, we'll go to small products that we have done. This is a project that we have done at Bandra BKC. So this is again an information desk that we did. So this is again a 25 feet long table that we have designed for one of the developers at BKC. So this is again an IT park house where we were designing this lobby. We were designing 3 installations. Both of them were mirror image. On the right, whatever you're trying to see, it will be a mirror image on the left. Every design we start with a sketch, then that sketch gets converted into a design 3D model, and then it goes through computational processes, the presentation process, and then the end outcome. So here what we are seeing is this is the 3D model that we have generated. So the whole model was presented to the client. After the approvals, what we did is we tried to divide this whole model into multiple pieces. So that all these colors that you're trying to see is multiple pieces that we try to use. Here in this case, to produce this project, we thought we will use the methodology of CNC machines by using WPC, cutting WPC as the main core material, and also use 3D printed material. So these thin strips that you're trying to see were 3D printed so that we can achieve that kind of a design. So we cut WPC, wood plastic composite sheets. We have cut them into multiple pieces, stacked them out, grinded them out. Then we sprayed that, after stacking, we did the grinding. After grinding them, you can see these holes. These holes actually carry steel cables. The whole steel cable, why we are using steel cables is so that the stability is there in the structure. Very important to keep the structure stable. That's very important. So all this process was done after stacking, after completing the whole project, I mean the installation, we had to spray this with composite marble. Nowadays, what we do is we want to protect our internal core material. So we have developed this material where the composite marble is sprayed onto the structure so that the moisture doesn't enter into your internal surfaces and doesn't crack. The whole idea is that. So by using composite marble spray, we are actually sealing the whole surface. Nowadays, if you want to even do Duco, you can use this as a base material and then use Duco on top. Then you can protect and seal your material in a much better way. And then there are no cracks that you tend to see throughout your life. So it's a good research that we have done to, to design and protect our products. So after doing this, you can see the mirror image, the same table doing 2 times, but not the same table, but it's a mirror image of the table. So it's not an easy task to get this kind of a design achieving to that precision. So we have tried to work this out to a precision, and we could produce it and make sure that it gets installed. So, the client has also inserted, we also had light inside it. It's not just the table, but we also had light incorporated into the table. So the whole product gets illuminated. So that's how the design was done. In this case, 3 installations we were doing. This was one of the installations where we used WPC as the base material. The other installation was this. This was a product which was supposed to be, this is just an art installation that we did for the same space in the lift lobby. So since we were in Bandra, we thought, we will have all the products that we were designing mimicked from the sea. So these were a few of those details that we tried to mimic from the mangroves, the roots of the mangroves. So we thought we will use that as the base, concept of the design and put this as an installation in the walls of this project that we were doing. So here in this case, even though we could have 3D printed this whole material, we could have just 3D printed the product and then installed it. But using 3D printing would not have been the right choice, because this is an installation which was also easily accessible for people to touch it. And probably at times, if you have kids moving in, they may also hang on it, So, hold on to it and hang just to see whether it has got that strength or not. So just to avoid those kind of accidents, we thought, we'll not use 3D printed material as the base material. We thought we'll use MDF. So we are also trying to use different materials in this project and try to understand whether materials can help us out. Multiple materials can help us out in terms of, as a research, we thought, we'll have these multiple materials and get this product done. So we have used 3 different materials. One is MDF, WPC. The other installation, we use Siporex, lightweight concrete blocks. So we have achieved this end outcome. So again, we sprayed the terrazzo thing that I was talking about onto the MDF to achieve, to give more strength to the product. So that's how the product went on. So these holes that you're trying to see are for the anchoring purpose that we have used. So end of the day, the product was installed on the wall. So at the back, we have mirror, and then the installation was done on the top, just to give that reflection of as if it is a one double piece, that's how it went on. So the third installation was about a screen, which was separating the baggage and the entrance lobby, the foyer area. So this is a baggage screen that we had done. So this was again mimicked from the corals of the sea. We thought we will have this kind of a design process, and we'll also incorporate light inside it. It's got multiple perforations so that, still having a screen, you don't see the baggage area from the lobby. So that's how it was done. We divided this into multiple pieces using the size of the concrete block, which we get usually 200 by 150 by 600 mm. So this was divided thinking that, we're going to use a Siporex block. Each block was again divided into multiple 4 pieces. So that's how these Siporex blocks were engraved using CNC machines. Each piece is numbered to a precise so that, we don't lose any of the pieces. One piece missing, that means we need to find out, trace it out again, make sure that the same piece is available there. Same design gets, engraved, and then we put it back. So that's the process that you're trying to see. This is the adhesive that we generally use for bonding the product. So that's how the whole product went on, one above the other. The stacking was done. Multiple pieces were joined together. Then at the top, we use H40 as a base top material, above which we sprayed resin again to give the strength. So that's how the whole design went on. So after incorporating lights inside the installation, this is how it looks like. So achieving from the start to the end, the design process, it's a lot of fun when you achieve your final product as you have designed. We are all happy. So complicated designs like this, not having any other knowledge in terms of the execution process, still we are trying to do this only by using machines at an architectural level. Attaining this it really gives you that happiness. So this is the kind of a design process, end of the day, which we could achieve. So those are the design details that you're trying to see, the multiple images of the site. Okay. So till now, what we have seen is these products that we have done, they had complications, but they didn't have complications to that an extent that we could lose our money, while doing these projects, only because the time span went on to such an extent that we couldn't complete the product in a given time span. That is one, and use more amount of labor to get the final product. So this is one of the projects that I'm trying to show you. It's again a table, but yes, it has similar kind of a design details that we had done earlier. But the most complicated thing is getting these lines that you're trying to see on the table to achieve that on the table as it is was the most difficult part in this case. So that was not the easiest thing, because we were using wood as the base internal design process. Then we were cladding stone on top of it. But these grooves that you're trying to see, those lines, those golden lines that you're trying to see, is basically brass. We used metal, the brass on top of this to achieve this kind of a detail. So, the mesh that you're trying to create in a 3D model is what we wanted to achieve as the end product. So the squares that you're trying to see, the polygonal surfaces, those surfaces were supposed to be marble, and the lines that you're trying to see are supposed to be your brass. So incorporating brass was the biggest challenge. That took us a lot of time, a lot of time to get the end product. So it was a big challenge. Yes, of course, by doing the project, end of the day, we achieved the design that we tried to detail out. So what you're trying to see is internally it was done in wood. Slices of wood were stacked together, engraved to get the design. It's very easy now for us. Then it's very easy for us also to unroll the surface, cut the marble pieces into multiple details, and then paste it. But inserting this metal piece was the most difficult part. Bending this piece is not easy, because while bending it also deforms, it changes its angle. Once it changes its angle, it's not easy to retain it back. It's not at a fluidic way. So the most important thing was that. So getting this in place was the toughest piece. Yes, finally we could achieve it. It took a lot of time to get this metal piece inserted into it and keep it as it is intact. You can see how difficult it was for our people to work on it, because we can't change the concept end of the day. And end of the day, we could achieve the design from the start to the end as it is that we are trying to see in the drawing. So, all of us were very happy when we achieved this as the end product. So not easy at all. You can see the number of lines, how they are moving from one end to the other. They are doubly curved surfaces. They are doubly curved bending thing that is happening with the metal piece. It's not easy. So the whole team was very happy at the end of the day. We thought, come together, click, because the toughest piece was there and we could end of the day achieve it out. Sunandra? Sunandra? You can hear me?
Yes, sir. You can.
Yes, there was a small
I
gap, but we
think network problem again. Sunandra, you can hear me, right?
Yes, yes, we can hear you clearly, sir.
Yeah, okay, done. So this is again, I mean, this is a staircase which we recently did. This, yeah. So this was a design of Mad Architects, New York. So we usually do. So we thought when he's coming here and he's going to teach Cinema 4D, we thought whatever he has designed, probably we will try and build what he has designed. So he gave us the opportunity that, select one of the designs that he has, put it on the Instagram page that he has. So we selected this design, which also is not just an art piece, but it is also a staircase. So it needs stability. That is the most important thing. It needs to have a structural design inside it. It can't just be a decorative art piece, a piece which has to be used. That is something which we wanted. As I said, everything is all about functional art. It is not just art. It has to be about functional art. So we thought we will design this kind of we will try and take the opportunity that Andrews has designed. We will take his design and build it. So for him also, it was a big achievement because till date, he's been just designing and posting it on Instagram. All the things are only in a 3D format. But for him, getting this executed was again a big challenge. So we took that as a challenge. We got the 3D model from him. We designed it. We 3D printed it at the initial stage just to understand the model. After compilation that into the live model, then fabricated in such a way that a mold can be made from this, because there are multiple pieces. That's not one piece. There are multiple pieces, same pieces, similar to each other. Multiple pieces were done. So inside this, it is hollow. So we inserted this structural pipe inside it with these horizontal steel cables. Then we covered this, we inserted this, filled this with composite marble again, so that the load is diverted equally inside it. So that's how the whole piece was done, with this hole inside. You saw the structural member inside it. Multiple pieces, they were joined together to achieve this kind of a design. So that's the 3D printed model at the initial stage, you can see. Then it got cladded on, each and every pipe was welded onto the central spine, and the whole process was achieved. Joining each and every small piece that you're trying to see, each and every step was, intertwined within each other to get that kind of a design process. So that's the design detail that you're trying to see end of the day. So every piece is interlocked one into one another. And still you can see that every piece is joined together to that central spine. So that was the difficult thing. Not an easy method at all to achieve this. So that's how it looks like end of the day. We tried to exhibit this in one of the exhibitions that was conducted at Geo, the design conclave. So that's how it was made. So using AI tools, we thought, why not try and understand how we can convert them into videos. You can see how easily I was walking on the staircase. It's so structurally stable. It's not that it's just a design and it's there on 3D platforms, but things can be executed. If you understand the technology in a much better way, things can be executed. Every design can be produced today, and they can be made structurally stable. That's also important, which we need to understand. So when Andrews was here, he was very happy seeing the structure. He was here, that's him, Andrews. He was here at Navi Mumbai. He was like very fascinated. He was so enjoying seeing the staircase, understanding that these unrealistic designs can be built by people of India. That's the reaction that he got. So today we are trying to collaborate with him at different products that he wants to do. Probably this October, we are going to install one of the installations in Austria that he is designing. We're going to do that. So these are the other images that you can see. Then going to large scale projects, again, we are doing a car showroom at Navi Mumbai. So this is a showroom that was designed by us. It's a G+3 building. So we wanted the whole structure to have the whole structure to be designed keeping in mind the chassis of a car. So we wanted to have the chassis of a car to be encased on the envelope of the building, and even the interior spaces to be designed similar to that. So keeping in mind the car as the prime motto, we designed the whole building. So interiors are designed like this. The spaces, we have also used AI at the initial stage to generate designs. So everything, the meeting pod, the reception table, this is already executed. Everything is designed keeping in mind the chassis as a structure. So that's it. These are the interior spaces that we have designed. So the project is still going on. That's the upper level. This the third level, third and the fourth level. These are the office spaces. This is the car showroom space where we have a central, a central dock where the whole car is going to revolve around in the double heighted space. So these are the other spaces of the same area. That's a staircase which is getting executed. Here we are trying to execute a staircase by using just 6 mm metal sheet. So, it's very easy now for us because we've already executed multiple projects. So 6 mm becomes very easy for us to have a sculptural staircase like this getting executed. That's how it looks like. This is an executed design. You can see each and every slit that you're trying to see is going to exhibit a person, the client whom he is going to sell a car. His details, his car, everything will be exhibited here in one of the galas that you're trying to say. That's how the staircase has been designed. So the staircase is like a museum to him now. So that's what we have proposed. The other staircase goes from the third level to the fourth level. That's how it looks like. So you can see the staircase. So that's how it is. So the facade is also actually like a chassis of a car. So this is how it looks like. So you can see that's the building that we have designed. So the work is still going on. So the top detail is like that. So this is here in Navi Mumbai. People can go there, see it, understand how the execution is happening. So the whole structure is getting cladded like a chassis of a car now. Okay, that's the car showroom that we have designed. Other than this is a residential project that we have proposed recently. So here at the bottom, you can see, you can hear me?
Yes.
So at the bottom, what you can see is a typical residential building. The residential design was not designed by us. This is one of the local architects of Mumbai. This project is at Juhu. This was the design that was given to us at the initial stage. It's a 2 BHK and a 3 BHK building plan, a typical plan that we generally tend to see. But we thought we will try and give a different kind of a building here, which has been mimicked from nature again, having these organic forms that we're looking at, completely fluidic in nature. Okay, so we generated a schematic design from using AI. On the left, you can see this is the kind of a design language that we wanted to follow on the building. So it was not an easy task to convert this into a 3D model. So we have generated this in AI and using Comfy UI and ControlNet, we tried to produce multiple iterations at the initial stage just to understand how these designs, now the technology has started taking place. We are trying to use technology now more, especially the AI thing. We are trying to use more now and try to convert our designs so that it becomes a different kind of a process and a methodology itself. So here we have tried to generate these kind of different different language of designs. So one of the colleagues, she tried to use this tensor as a script, a grasshopper script, to understand the openings on the building and create this kind of a design process. And then these details were incorporated into these kind of design processes were incorporated into Comfy UI, where we try to generate different facades. Different kind of facades were generated using the software. So multiple iterations we try to understand. There were multiple failures during the process. This is the script that we generated first, and then started inserting the two-dimensional images that we have created in Rhino, inserted it into the software, tried to create multiple iterations, but end of the day, we could achieve one of the iterations which we tried to follow and then create that design. So this is the final building that we proposed to the client. So on the top, we have got a terrace landscape with a deck. The idea of this deck is to make sure that our buildings are future ready, because today we are seeing all the transportation that is happening on road, but sooner or later, I think drones are something which might land up as our mode of transportation. So we thought, why not create or propose one deck on top where at least these drones can start landing on your own buildings. So probably future maybe that. So that's what we're looking at today. So this is the building that we have designed for Juhu, for Andheri. So keeping the building plan as it is, right? Keeping the building plan as it is, keeping all those bylaws, the fungible bylaws that we are looking at, we thought we will not, lose that context of the FSI as the permission, but still have these kind of building proportions into the facade and create this kind of an language that we're looking at today. So that's the facade that we have created. It's just in a proposal stage right now. Yet a lot of things will change probably, because at minor areas we are coming out by, let us say, by 50 centimeters to 100 centimeters. Probably we need to convince our municipal engineers in a much better way so that they agree to this kind of a language of a design. Then this is a project, again a proposal project, a residential project, G+13 building. It's a bungalow that we are trying to do. In this case, the whole building is reversed. The living room, the kitchen, and the spa is on the top, and the bedrooms are below. The owner is a lover of cars. So we thought we'll design the building in such a way that his car can travel up to all the floors. He can take his car up to his bedroom as well. The whole design language was on that fact. So we designed this building like this, keeping the sustainability in place. There were multiple openings. All the surfaces that you're trying to see are going to carry ducts, electrical cables, some information cables, etc. We have multiple levels where we're going to grow landscapes so that there's good amount of sense of sustainability into the building. So these are those plants that you can see, multiple floors. Centrally, you can see that this is the car lift. This car lift takes the car up to the living room and up to the bedroom. It's very easy for the client. We have created that kind of lobbies, so that the car can actually be parked into his own lobby, and then he can go into his bedroom. The whole idea was that. The biggest challenge in this case was the Vastu consultant that entered at the later stage. So because the whole building was organically designed, the Vastu consultant was not agreeing to the thought process that such kind of a building can really help the clients. So he says that every space, every corner has to be rectangular end of the day. But fortunately, the kids, the sons of the client, they were of the opinion that they wanted to have this building as it is rather than having any changes. So when the client dominates the design, then the Vastu consultant has to take his foot back. So luckily, in this case, the Vastu consultant took his foot back and said that, we can keep the building plan as it is and just insert copper, metal pipes inside the slab while casting in a rectangular format inside the slab. And then, we can attain Vastu in place. So we were lucky enough that, the Vastu consultant had to agree end of the day to all these curvilinear forms. And make sure that the building plan doesn't change. So we were too lucky enough. So the building plan is attained as it is. So that's how the sections are. You can see them. The building looks like this. So we'll quickly move ahead because I think we are short of time. This is again a proposal for.
Sorry, I'm interrupting. Can we time it in the next 5 minutes? So we have some questions. Otherwise,
Yes. I think we're almost done.
almost.
Projects.
Okay.
Yeah.
Great.
So this is a project. Again, it's at a proposal stage. It's an office complex that we are doing for. It's a high-end office for one client, single client. This is at Jamnagar. It's going to soon start now. So that's how the proposal went on. So that's how it looks like. So end of the day, here in this case, because it's at the proposal stage, we are also trying to make models and do the rendering in AI. So AI is trying to help us out in a much better way to generate our details as it is that we want to. So no changes. This is a residential project that I'm doing at Juhu again. It's a it's a duplex, 11th and 12th floor, 6,000 square feet of a space, which was completely designed using fluidic forms. So the work is going on. These are 3D renders that you're trying to see. So every piece is designed to an extent that we can build them. So that's a mandir. Mandir can be designed like this with a staircase going behind with a handrail on top. So that's the bed. So all these things that you're trying to see is now each and every piece is getting executed now. These are the design processes. That's the design language that we are trying to work with. That's a wash basin again. So in this project, other than the fabrics, we are executing everything. whether they are sculptures, wash basins, WCs, everything we are executing. So the best part is you don't have to go and procure anything from the market. So that's the bed that we're trying to see. These were all functional pieces. Now we're going to see art. This is art, one of the art pieces that was designed by B.V. Doshi sir long back in 2020, just before COVID. This project had come to us to execute basically. So for the first time, also, this is one of the sculptures that only sculpture that B.V. Doshi sir has designed. We thought, luckily we got this to execute for him. So we thought we'll use 3D printing as the base product, so that we 3D printed the whole model, then used reinforcement in a skeletal format of a fish, which was put inside. Also, for the first time, we were casting resin. We were casting terrazzo as the prime product, prime material. Okay, so here we casted it out using terrazzo, using the 3D print technology as the focus. Finally, we achieved this kind of a design methodology now. So, after COVID, it went to B.V. Doshi sir. That was the last image that we could get from him. So finally, we were blessed to do this kind of a project for him end of the day. Then we also do a design competition come workshop at Folds. So this is Unfolds. Last year we did 0.3. This year we're going to launch 0.4, which will happen in July and August. So these were the design entries that we got and the winners. So these are multiple things that keep on happening at our space. So we had almost 120 students this year who were taught by these geniuses like Carls Bannon, and then Brian, and then Andrews, who had come down, and by me as well, was teaching fabrication. So multiple, for 6 days, this workshop happened where we taught all these things, how they can be built, how they can be designed using softwares and tools. So this is, we had also some conferences that happened. And then at the end of the day, we had council president also being present at the event to present the awards. Okay. So these were the things that we tried to do. Then using as the language or the AI as the language, we started understanding that AI can
Voice is
be
breaking.
used in a much better way. So from a sketch,
I know it's.
you can see me, you can hear me,
Yes, yes, yes.
you can see, right?
Yes, yes, we can see.
So converting those drawings, those sketches, these sketches that we keep on making, and then today, since AI as a tool is helping us out in terms of generating these kind of designs. So converting that sketch, the elevation to this was the best part. So we had converted the sketch into a 3D design now. So we can also do animations and all. So AI as a tool, it's a very good tool to do presentations at the initial stage. It has not even entered into controlling machines now, at least in India. Maybe abroad, I don't know, but in India, we are still at a premature stage. So slowly, we might start focusing on to much better ways and much better methods. These are other presentations that we have done for one of the project at Karjat, just using AI at the initial stage and at a raw stage. So these are all just, this is the building that I showed you, using that as an image, how we can convert that into a different kind of a bungalow using parametric language. So all these things are possible today. This is one of the columns that we had designed. These are AI generated columns. So using your own language of design, you can generate new designs. That's the part.
Sir, your voice is breaking, sir.
Yeah. We are back. Yeah.
Yes, sir.
Okay.
Since we are
So we are
running
almost
short.
done. Anyways, we are almost done. So we can go to the questionnaire. So these are few of the AI generated images. So I feel that, probably through using AI, how can I tell people that, are we future ready or not? So what would be the mode of transportation tomorrow? How our buildings will look like? How our vegetation, how our landscapes will look like? So these are few of the images that I'm working on at our office. So I always say that, are we future ready? If not, third, how we can get in. Am I audible to you?
Yes,
Yes,
sir.
just about, yeah.
So I always say that, if we have to be future ready, then what are the steps that we need to take? How do we collaborate with each other? Who are the different people who are ready to come together to do this kind of research and lift up the architectural language today in India? So that's the end slide for today's lecture. Thank you.
Thank you, sir. Thank you so much, sir, for your insightful presentation on the integration of technology in design and practice. So it was truly a unique opportunity for us to witness a seamless assimilation of art, architecture, and technology in practice, especially very precise kinetic designs and innovative designs inspired from the nature. When many designers, hesitate to experiment with the materials and forms, you just boldly demonstrated it through your practice, pushing the boundaries and inspiring us all. I'm sure everyone, especially the students who are attending, got motivated to boldly derive forms in their mind, whatever in their mind, and just transform into the product. We really appreciate your valuable insights, sir. So with that, we now open the floor for question and answer session. Because of some network glitches happened in between, we are slightly short of time. So now, if you all have, anyone have any questions, can ask him. So I have a question. Basically, I want to know about, sir, what are the limitations of using 3D technologies, 3D printing and other technologies for innovative material applications in the construction field? And additionally, when conceptualizing a design, do you finalize the material selection based on the design, or do you first research the suitable materials before formalizing the design? So how the process happens?
It all depends upon how you're taking up the project. Let us, if you're doing an interior project, and then you have vast variety of materials that you can use. Okay. So if you're using technology as a part of your design, because when you're designing, you also need to understand, because especially in our case, the kind of projects that we are trying to do, technology is something which is incorporated into our design from day one itself. So we know what machines we want to use. So after working for so many years, we understood that there are certain kind of materials that we can really play around with. Okay, so 3D printing, yes, is one of the modes that we are using today in a much bigger way. Every project that we are doing, 3D printing is something which we are using in a larger scale. But there are limitations to 3D printing as well, because today we are using 3D printing as molds, only for mold purposes. We are using only for mold purposes because the end product can't be used as a stable product, at least today. We don't know what would be the future, but in one of the projects that we did for the column that we 3D printed, where 12 mm thick, where we used pellet extruder, where using a 12 mm nozzle was through which we printed this whole column. But the column was very stable. It also took the structural stability, where 5 to 6 people are standing on it. So that's the stability that it can take. So we don't know what the future would be, but at least in today's case, we are still at a premature stage, because technology is not easily available to architects. That is something which we also need to understand, because architects are still facing a lot of problems. Technology should be taught in the school itself. That is something which is not happening. People are trying to learn technology once they go abroad, doing masters, or probably in some of the schools where we are trying to see that they are trying to adopt technology at the initial stage. But again, to what extent they are trying to work in the institutes also matters. That's something which we need to understand. So if they are used in a much better way, probably we will have a lot of people coming together, understanding the pros and cons of how, especially the glitches that happen. The errors that we are talking about while constructing, they do happen a lot. If they happen at the school level, it is okay. But if it happens at the production level, then it becomes a big loss for everyone. So, but in our practice, that's happening multiple times. So a lot of losses do happen while practicing in our case. So using 3D printing is something has become much easier today now, because we have understood how we can multiply our products now. So 3D printing at a premature level, at a smaller scale, you can build large products, but using smaller pieces. Multiple smaller pieces, gather them together using reinforcement, you can create your own products now. You can actually build buildings also. You can literally build buildings by pouring concrete into it, by putting steel members inside it, and you can derive your own designs now. So that's possible. You don't have to go for concrete 3D printing as such. The way it is getting 3D printed today, what I see in the market. Recently, I was at one of the lectures where we had IITians from all over India together, sitting on a 3D print conference. We were all talking to each other, trying to understand whether the concrete 3D printing has really developed a lot or not. It is getting developed. People are building buildings, but all linear buildings. So that's the problem. We are all building linear buildings. If we have to build linear buildings using concrete 3D printing, the technology is a waste then. Why? Because it becomes very expensive. So at that stage, building linear buildings, I don't think then better is to use precast buildings, precast methods to construct linear buildings. If any kind of these fluidic designs that we are looking at, the mimic buildings that we are looking at, then I think concrete at our stage, it is a little failure in India today. Yes, by doing a lot of experiments, we can achieve that. But I'm also seeing that the plastic pellets that people are trying to use today, that we have also used, because they are also recyclable. Best thing is the pellets that we are trying to use is recyclable. When they're recyclable, one, and they're taking the structural stability, and they're very easy to transfer from one place to the other because they are lightweight. Then the thing is, probably concrete may get obsoleted as well, and these kind of things can come into place. If we start incorporating some steel members into it, then we can create wonders, probably.
Thank you so much, sir. So
Yeah.
now I would like to invite our Dean, Professor Aparna Surve ma'am, to deliver vote of thanks.
Yeah, thank you so much. Actually, I can see that when you began your process, I think the idea itself, wanting to do something, then wanting to make something, and then accessing technology. I saw your struggle three-pronged, and how you kind of doing back and forth and trying to bring it together to create that balanced expression through your projects. Now, whether it is you want to make it, you want to think different, you also want to use technology. I think this is something, I mean, I've heard a lot about and seen, but today I felt that having this opportunity to see your work from start to, and now you're talking about AI. I think it is really revealing the amount of what you're talking about, financial risks that you're able to take because you're envisioning and you're also having that conviction that, we'll do it. So these are the things actually I think people like you, I think all of us at some stage, we need to kind of transfer it to the younger generation so that, this kind of innovations keep happening. So I think thanks a lot. And I think we will collaborate. Of course, this is just the beginning. This is a first dialogue for this conference. And during the conference also, we are going to listen to you. And in between, if you can think of something, I think we should fabricate something or something, whichever comes to your mind. We think we should do that. And one more thing I wanted to kind of appreciate and acknowledge is that on one hand, you are breaking the rules. You're trying to break the rules about the norms, about how we envision design, and so on and so forth, which is a process that frees you. And to achieve that, you're actually following the parametric rules. You're taking that efforts in learning something. So this is how you kind of make that balance. I think you've chosen a very unique path, and I congratulate you for this. And thank you so much for
Thank
coming.
you.
Yeah. Right. Thank you once again.
Thanks
Hope
a
to
lot.
see you. Yeah.
Great.
Yeah. Thank you, Mary.
So before leaving the meeting, I would like to invite you all to register for the next webinar. So that is on 31st of January by Professor Aniruddha Paul and Professor Ankush Chandran on data science analytics. And on behalf of Council of Architecture and D.Y. Patil School of Architecture, I would like to extend our heartfelt thanks to our speaker, Architect Krishnamurthy sir, and co-convener of the conference, Professor Aparna Surve, Dean of D.Y. Patil School of Architecture, and as well as all our participants for taking the time to join us today. Thank you so much.
Thank you.
Thanks a lot. Thank you.